Energy production and consumption are major drivers of global emissions and climate change. A better integration of renewable energy sources into the existing energy grid, as well as more flexible consumption, are necessary to effectively reduce the carbon footprint. Ebalanceplus, a European-wide initiative, is seeking different solutions to manage energy supply and demand in a more sustainable and efficient way. What the energy management of tomorrow may look like is currently being tested at 4 locations across Europe. In the French city of Lille, researchers are focusing on European building stock, as this still accounts for 40% of the EU's energy consumption. The researchers' laboratory is a building complex that contains the Technical University of Junia and the Catholic University of Lille, which was founded in 1885. In total, 3 buildings are part of the pilot. Thousands of people work there every day.
The particularity of the university is that it's in the city centre, located in old buildings. We had to re-insulate a lot of buildings, so it's not only the active technical part, it's also the passive insulation. And so, of course, we have to pay a lot of attention to the architectural part. The goal is to be carbon neutral, obviously, for our buildings. So we are trying to use renewable energies and to reduce our consumption as much as possible.
To achieve this, the researchers have equipped the building with several measuring devices. In addition to other renewable energy sources, energy is produced by this photovoltaic system.
We have behind us a photovoltaic power plant of 1,200 square meters, which can produce a maximum of 175 kilowatts, depending on the climatic conditions in our region.
The concept is that the entire energy system, which is located mainly in the basement of the university, can be operated by a single control unit.
Here we see the graphical interface that allows us to control the whole building and automatically control the air handling units, the heating substations, the temperature management in the rooms according to the presence or absence of people in the rooms, because we have different temperature levels.
Many sensors in the building ensure that the different energy networks can connect and communicate with each other. The data that is collected is stored on servers for analysis and evaluation.
The system collects all the information on databases. These databases allow us to store the information and share it with our various partners. We have developed an interface called an API, which allows us to exchange data in complete security with the various partners, and the partners are able to send us instructions how to reduce our electricity consumption, and thus to bring flexibility to the electricity network.
In the event of a grid overload, the local energy supplier can also send a signal that the university needs to reduce its consumption or go off the grid completely.
There are algorithms which are able to optimize our internal consumption, whether it's related to costs or CO2. We have in real time the emission factor of the electricity produced by the network, which we are able to optimize. We have other algorithms running, which are listening to the signals of the network, and which will take over in case that the network asks us to fade out.
The Lille demo site is providing valuable data and insights that can inform future energy policy and innovations. By testing and refining these new energy management solutions, the project is paving the way for a more sustainable and efficient energy system in Europe and beyond.